Hi. So this is a nice, small, intimate group, and that's great. I'm Janet Rankin. I'm the Senior Associate Director at the Teaching and Learning Lab. And Becky and Chad asked me to come and just talk to you a little bit about thinking about what you're going to put in your videos, planning the videos, and that kind of thing. So I work with faculty and grad students for the most part. A lot of times planning courses, designing courses. And there's a real nice analogy between what you guys are doing with your videos and what faculty do when they plan classes or when they plan their whole course. So we're going to use that model, and then I'm going to give you the opportunity to think a little bit more about the video you're going to make if you haven't already. I mean, I know you've thought about it a bit. And then think about specific things that you might do in order to really drive home the points that you want to, define what the points you want to make are, what you want students to learn, and then come up with ways to make sure that students learn what you want them to learn. All right, so if you could just take out the first handout. This is a handout, something we use. It's from this book called Wiggins and McTeague, and it's called Backward Design, or Understanding by Design, and he has a part in there called Backward Design. Now, let me ask you a question. I know you had a proposal for what video what you want to do, and you've also latched on to the topic. These are like the classics from the archives or something, yeah. Revisiting the classics, right? So you know what experiment you're going to do, and you've thought a little bit, somewhat about what you're going to do, but you haven't filmed anything yet, correct? Okay, all right, good. If this is totally not working, like if I've totally missed the mark, somebody should let me know, because otherwise I'll just go on and we'll all be wasting our time, okay? Hi, welcome. So what the idea behind this is that you start with where you want to go, and then you decide what you want to do and how you're going to get. Then you decide how you're going to get there. And I liken it to that if somebody were to just like come in here and like put a blindfold on you and put you in the car and then drive somewhere, it would be kind of, well, it'd be scary. But when you got there, you wouldn't know where you were, and you wouldn't know how you got there. And so a lot of the experience would be lost. So for your sake and for the sake of the people that are watching the video, it's important to define the learning outcomes, which is where you're going to go before you take anybody there. So we think a lot about where you want to go. And then once you know where you want to go, you can say, OK, do I have to take 93, or can I take the back roads? And is it rush hour or whatever? And you can start to think about the situation. But you kind of have to know where you want to go before you can figure out what you want to do. A lot of times when people plan classes, or if you've worked with faculty members, if you're a TA, a lot of times we just sort of look at the topics. We open the book and look at the topic list in the book, in the textbook, and we say, oh, OK, I have to teach about the first law and the second law of thermodynamics, fine. But people often don't define what they want students to know about the first law and the second law of thermodynamics. So it's really, really important that we think a little bit about how to define that, define what we want students to know about the topic. So that's an important thing to remember. And then, so then you're going to design, based on what you want them to know, you're going to learn design the experiences accordingly. That's the whole outline for what I'd like to do today. The next handout, there's a handout that says learning outcomes. And how many of you have heard of learning outcomes? One? OK, so I think Marzia should have heard of them, but in the teaching and learning business, we say, well, every syllabus, every course syllabus should have learning outcomes in it. But point of fact, the fact that most of you guys have never seen learning outcomes means that most syllabi probably don't have them in it. However, it's really, really important. And this is how you know where you're going to go, and how the students know where you're going to go. And just to summarize this document, again, I'm not going to read it to you, but the idea is that they often have, you can divide them into 3 chunks: skills, knowledge, and attitudes. So I don't know about these experiments, but it's not like by the end of this video you will be able to solve equations in MATLAB. Like, that's probably not a skill that you're going to try to teach in this video. So skills, I don't know. I have a sense that probably what most of you are trying to show people using these videos are not skill related, but they might be, and that's totally fine. And then knowledge is sort of what students should know and understand about the topic. So they should be able to compare and contrast They should know, based on a pH indicator, whether a solution is acid or basic. Something like that. It's not just acids and bases. That's the topic. What do you want them to do with the topic or know about the topic? And then attitudes, and again, I don't suspect that these videos, even though they're going to be great, are going to necessarily change students' attitudes, although they might actually change students' attitudes about science or about the topic. And that's a totally legitimate goal. And you should, if that's something you're trying to do, you should probably say that. So we're going to give you an opportunity to sit down and think about what you want the goals, the outcomes of your course to be. You'll hear words like learning outcomes, learning objectives, learning goals. Lump them together. They're the same thing for the purposes of this discussion. It's helpful, again, to have it in this. There's an italics sentence here. By the time students finish the course or the video or the workshop, they should be able to. And then you give a verb. And then I have some example verbs: explain, list, describe, demonstrate, calculate, report, whatever it is. And again, this is kind of special because you're doing video, right? And on the back and the second page of this handout is a little triangle. This is a classic taxonomy of sort of cognitive development or cognitive abilities. It's a triangle, and it starts with the most basic one at the bottom, remember. And then it builds up to higher and higher ordered skills, really, or abilities. So understand, apply, analyze, evaluate, create. You know, maybe you are at the remember level. Maybe you are at the understand. I think you're probably a little bit further up. But depending on what you want people to do, you do different things. If you just want students to remember something, you probably say it 25 times, and you come up with a mnemonic, and that's it, right? And then they remember it. They may not understand anything about it, but they remember it, right? My 6-year-old can spell, what's the longest word? Something about silicova caniosis or something. And I think he can spell it, but he has absolutely no idea what it means. He's just memorized how you spell it. So if you want somebody to be able to memorize something, you do one thing. If you want them to be able to analyze something, you have to do something else. So it's important when you're thinking about what you want your video to accomplish to really try to put these into these categories, because then you can do the right thing to help them get to where you want them to be. And the rest of the handout just has extra words to think of if you're running out of words. So what I'd like to do now is just to give you maybe 10 minutes or so, and you have a template here, a handout here. And so this is a worksheet that I hope will fill out by the end of this session, by 5 o'clock. And it has the topic, which you know, that's the easy part. You've already defined that. And also, I want you to think just sort of a free range, free think about why you picked this topic. Why is it so cool? Why would a K through 12 student want to see it? So now that you've sort of defined why it's cool and defined it, and some of you have actually started to think about what students should get out of it, I'd like you to break up into groups, and it's okay if you're not doing anything similar, and just so that you can bounce ideas off of each other, and write down, try for 4, but maybe 3 or maybe 2, it really depends, about what you want students to get out of the videos, what you want them to know, be able to do, understand, what you want their attitudes to be by the end of the video. And I've started it for you by saying, by the end of this video on blah, 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 students will be able to, and then I encourage you to use the taxonomy, the triangle, or the associated words. They will be able to remember. They will be able to understand that, that penicillin, penicillin is produced by mold, and that it prevents the growth of bacteria, or whatever it is. That was the last one, so it's in my mind. Whatever it is, but really make it something that the students can look at it and go, oh, I get it. By the end of this video, this is what I'm going to be able to do. Sign me up, right? So try to do it like that, and try to get at least 2 good ones, but try for as many as you can, obviously. All right, so let's do maybe just try to get one learning outcome from everybody. And what I'm going to do is I'm going to try to write them up on the board. And we're just going to look at them and see if we can tweak them a little bit, maybe make them stronger, and maybe think about, in some cases, think about how to move them up in terms of the taxonomy and down in terms of the taxonomy. And again, you're the directors. You know best about where you want to pitch them. But just so you can see that you can actually change where it's pitched, even if you have the same, an outcome, you can move it up or down and make it higher or lower on the taxonomy. From what I heard, you guys are doing great, and you've got some great learning outcomes. So why don't we start, Tyler? Why don't we start with you?
I'd say understand how scientists can set up experiments and be able to analyze the results. Or I should say, understand how scientists set up an experiment to ask a question and then be able to analyze the results.
Set up an experiment.
I'm sorry that was so long.
Okay, so let's just I just broke it up into two, because why not? You got two of them already. So this is great. Understand how scientists set up an experiment. You could think about whether by the time they watched your video, because you could say, okay, by the end of this video, you will be able to set up an experiment. Now, I don't know whether you think they can do that or not, so that's just something to think about. Well, you will be able to set up an experiment to ask a specific question or to ask a specific question, and then analyze the results from an experiment. That's a great one, and that's definitely a higher order, higher order objective, and it's great. So, anybody have any comments or questions about this? I think it's a good level of generality, specificity. It's not so broad that it's like whatever, and it's not so general that it's not really useful to anything else. So it's a good, it kind of hits at a good point. So, great. Okay, Mac?
So mine is create your own geometric shapes.
Went for the top of the pyramid.
Yeah, going straight for the top. that's pretty much the whole video, hopefully.
That sounds so cool.
Create your own geometric shapes without any estimates or assumptions.
Estimates or what?
Assumptions.
Okay, create your own geometric shapes without any estimates or assumptions. Okay. So that's kind of it's interesting because that's kind of a skill, but it requires some knowledge.
Yes, and also some attitudes, because I think a lot of it is you have to, be willing to go out and experiment with things and try it for yourself, not just, tell me how to do it.
Right, and so
right way is.
I would encourage you to make that evident to the students at the beginning, because it's part of it is that, well, I'm going to show you this, and then you're going to be empowered, So, and that actually can go pretty far to help change the attitude. Just the fact that you're saying it, and you're going to say, yeah, I'm going to give you this, but this is what I'm going to give you in this video, or this is what I'm going to help you get in this video. So I would be explicit about that as well, for sure. Okay, Aaron?
Calculate the period of Foucault's pendulum at their latitude.
Count the period I know I didn't spell this right. Did I get it? Pendulum with what?
At your latitude.
So this is probably for high school students?
Yeah.
Okay, at your latitude. Okay, and are there sort of things that they would have to do or know or understand before they can do this that your video is going to help them do?
Well, there's an equation that relates latitude to.
Oh, okay.
You mean you understand what latitude is?
Right, right, okay. I didn't know whether there was some sort of preliminary, I guess it's preliminary measurements or whatever. So understand how Foucault's pendulum is constructed or something could be another one. Yeah. Okay, good. Marcia?
For me, it's like they will understand that there are different forces and I will show that there is gravity, there is like magnets that they can absorb.
Okay.
And then I will show that there's another force which is electrostatic, and they can create this force by rubbing stuff to each other. And then also they can create new experiments by, for example, rubbing a balloon or anything to different stuffs and see whether it's a positive or negative charge and how they can do it.
So understand that there are different forces.
Yeah, for example,
Right, gravity. No, I understand. But
yeah.
that, and that's actually a kind of a tall order, I think, depending on how old the kids are.
Yeah.
That I think they don't think about, children don't necessarily think about why something's moving or why something's falling or why, you know.
Yeah, I just want them to know that, for example, just any two things that they absorb each other is not because of electrostatic. So I don't want to have this interpretation for everything. So I have to show them that like, if something is falling, it's not because of this. It's because of another force.
Okay, there are different forces that can act on objects or that act. And then what about electrostatic forces do you want them to understand?
They can create new experiments and learn that some objects will get negative charge or some will get positive charges.
So they would also have to understand, I think before this, perhaps, is that they have to understand that there's positive and negative charges.
Yes. So the positive or negative will repel and the positive and negative will absorb.
And I think I might think about and be able to test, perhaps, whether charges are similar,
Right.
adjacent charges are similar or different, or I mean the same or different. So I think I would encourage you to focus, to again think about if it's about electrostatics, sort of focus in on the electrostatic part, and then go out and say, okay, and then you're also going to understand that those aren't the only forces.
Yeah.
So start with the focus of the video and what you want them to know about that, and then contrast it to the stuff that's not necessarily the focus of the video. Okay?
I would say the main one is understand how an object can sit on the water without sinking.
Okay.
And
And what are you going to, well, we'll get to that. An object. So they really are going to understand that about surface tension? You think they're going to really?
I think at least they will understand the concept. Maybe not necessarily at the molecular level, but
Right,
they
right,
will
right.
understand what is the concept.
Okay, so maybe I might think about this as sort of be able to describe, be able to describe why an object can sit on the surface. So that you're asking, and again, it depends on the level. You know, if it's high school, then maybe you can start to get into some real explanations. But if they can say, well, you know, the surface is like, a piece of paper, or it's like a bubble gum, or it's like whatever you want to, whatever analogy you want to make. And if you want students to be able to make an analogy so that they can see the surface tension, this is hard because we all know what we're talking about, but see the surface as a surface, the surface of a liquid as a surface, that maybe that's where you want to go with it? I don't know.
Something like that. It's basically the force between the molecules that.
No, I know. I actually have a PhD in material science.
This is
so
very
I know about it. I know about surface tension. But again, whether students, like fourth graders, don't necessarily know anything about atoms. They have not learned about atoms in fourth grade.
Yeah.
So depending on where you're, where you're where you're pitching the video, you can't begin to talk about intermolecular forces. So again, depending on what it is, but sort of being able to describe is often a good thing because it lets students put it in their own words, and then that shows that there's some level of understanding. Now you can't test it because you're not there when they're watching the video. Okay, good. Maria.
Okay, so I guess I'm not sure if it's necessarily understand that solids will change the melting temperature of melting point or boiling point of water, but we do want them to be able to apply it to melt snow or to make ice cream.
Okay.
So is it understand if we're not going to go into detail of all
Right,
the molecules, if we're just going to talk about it? So.
How about they will be able to add things to water to change its melting or freezing, melting or boiling point?
Yeah.
And again, this is not high school or college. You wouldn't write this in a college
Yeah.
level learning outcome. Add things to water. Okay. Okay, that's good, and that's something that they can know whether they can do it, right? Are they gonna? What else?
We were also going to talk about understand the effect of concentration, so it's proportional to how much stuff you add to the water.
Okay, so maybe understand that the concentration, or maybe know how the concentration affects the melting of the vaporization.
Yeah.
Okay, I'm not gonna write that one down.
No.
Jean.
So the main point that we wanted them to learn is that we want them to understand that pure water does not conduct electricity. And
Okay.
then I guess the corollaries are, know that there's conducting versus not conducting things, and that tap water is ionized. Or not that word, but has stuff in it to make it conduct electricity. So.
We don't want them to go at home and be like,
I think. How about be able to describe why plain water doesn't conduct electricity and water with impurities does? So again, it's a described thing. So it doesn't necessarily mean they could do it on their own, but it means that they at least have taken in what you've shown them enough so that then they could describe it to somebody else. So describe how loosely speaking. I mean, it wasn't exactly what I said, but it's the same kind of thing. And they do follow, right? So first they can add things, and that's kind of a procedural thing. And then they can explain why what they added did it. Or it's cyclical, perhaps. Okay, so hopefully you have other outcomes that you've written down as well. And hopefully this was a useful experience. I want to just touch on one more thing. And that on the back of the on the handout the template that you've been filling out, it's called Learning Experiences and Instruction, and that's the second part of our little box. So it's how you're going to get them to be able to achieve those learning outcomes by the end of your video. And it's a lot easier when you're teaching a class, or a course where you've got students, day after day for a whole chunk of time. You just have a video. So, you're limited by what you can do. But what I'd like you to do, and we won't do it now, but I think it would help you for planning your videos if you can think about, okay, I've decided what I want them to know, be able to do, et cetera. And then what am I going to do in the video that's going to help them get there? It's going to help them be able to do it. There is on the back of the backward design, it's kind of in a crazy order, but I did it just to save paper. Are some things that you can ask students to do to help them get a little bit engaged with what you're doing. So you can have them answer questions. I mean, you don't know whether they're right or not, but you can ask them to stop the video, or you can say, what do you think is going to happen? And then you can wait if you want. So there's a whole number of bulleted lists here about what you, bulleted suggestions about what you might have students do while they're watching the video, or after the video to practice. One thing, if you remember one thing about what you should do, is that there's been a lot of good research done about what makes demos, what makes watching something a useful learning experience. And we all think, oh, I'm going to show you this experiment, and you're going to remember it forever, and it's going to be wonderful. But point of fact, it's not true. And Eric Mazur, who's a physicist at Harvard, actually did a study, a quantitative good research study. And he showed students demos in his introductory physics class at Harvard, and found out that it had no effect on the average number of misconceptions, or the way that they had no better understanding of how momentum transferred when they saw, an air track collision or whatever. It didn't help at all, unless he made them make a prediction before they watched the video, before they watched the demo. So at any point in the video, if you can say, okay, I want you to think real hard, what do you think is going to happen? Or what are our problems going to be when we try to figure out this right angle? Or what could go wrong? Why might we not see any bacteria forming in this part? But ask them to think about something. And again, you have no control over what they do when they're watching your video, but you can at least start it. So if you do nothing else, I would encourage you to ask students to think about stuff before you show it to them. Again, this element, that the prediction is really important, and also this element of suspense. We all get drawn into it, and it's very powerful. That if you kind of leave them hanging for a little while, they're waiting, they're watching you more carefully, because they're hoping you tell them what's solve the mystery for them. So that can be very, very effective. If you have any questions when you're making the videos, or when you're thinking about planning the videos, feel free to contact me. I don't know if you have my contact information, but you can email me at jrankin@mit.edu. And my office is just down the hall, 5122. I'm in most of the time. Not that I'm available most of the time, but feel free to stop in, and we could set up a time to meet if that works better. So I hope this was helpful, and it sounds like you guys have some great videos. So I'm really anxious to see them and looking forward to it. Thank you.